Hello everyone. For this tutorial video, I'd like to explain how to find tangent lines and derivatives of parametric equations, which are different than the normal derivatives because of how parametric equations are different than normal functions. But we can see, using the chain rule, we can get an exact formula for the derivative. So we will do just that. In particular, if we remember from Calculus 1, the derivative of g of x equals the derivative of f of g of x times the derivative of f of x. This means if we assume g of x is y and f of x is x, and we are using t instead of x because of what a parametric equation is, then we see change of y with respect to t equals change of x with respect to t times the derivative of function with x as the input, where x is a function of t rather than a single variable. Since we want the derivative in terms of change of y over change of x, like with the normal derivative, we see that the derivative of the function with x as the input gives us exactly that. So in conclusion, change of y over change in x equals change of y over change in t divided by change in x over change in t, provided you do not get division by 0. If we wanted to take change in x over change in y instead, we would simply flip the fraction. So if we wanted to find the tangent line at 0, 4 of this parametric set, we would take the derivative of y with respect to t and the derivative of x with respect to t, and see that the overall derivative is a ratio of these. We next plug in the coordinates for the tangent line point, so 0 for the x and 4 for the y. For the x, we get t is either 0 or positive or negative 2. And for 4, we get t equals positive or negative 2. We see because both 0 and 4 give positive or negative 2, we will actually have more than one tangent line, which never happened with normal functions. But we will see why this is valid soon. In particular, if we plug in t equals negative 2 for dy over dx, we get negative 1 over 8. And for t equals 2, we get 1 over 8 as the slope instead. In conclusion, it looks like the slopes will have opposite directions, but have the same general steepness, which we can verify is accurate with the graph of the function. And this graph also explains why there are two derivatives at this point, because it approaches the same point twice from different directions, which was never possible with y being a function of x directly. We can see a horizontal or 0 tangent is when the numerator is 0, and likewise a vertical or undefined tangent is when the denominator is 0. So if we were given this set of parametric equations, we would take the derivative of x and y with respect to t, see that it has a horizontal slope when 6 times t equals 0, or simply when t equals 0, and it has a vertical slope when 3 times t squared minus 1 equals 0, which means in turn t must be positive or negative 1. In conclusion, we graph this function to see that this is true. At t equals 0, the slope is perfectly horizontal, and at t equals 1 or negative 1, the slope is perfectly vertical. And this is never true for any other point. If you are curious, higher order derivatives of these types of functions would simply be the derivative of the first derivative we derived earlier, with respect to x rather than t. So if we wanted to take higher order derivatives than that, we would simply repeat the process, i.e. use the same formula once you calculate that derivative. Now that we have figured out how to find derivatives and tangents of parametric equations, we can figure out integrals/areas of parametric equations next. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.